Hi, I'm Kyle with Kimray, and in today's video, we are going to be covering high pressure control valves. If you find this information helpful and want more, Kimray does in-person trainings. Visit kimray.com for more. So high pressure control valves do a lot of different things, depending on what you pair them with, whether that's a pressure pilot, whether that's a level controller, a level switch, or maybe it's a thermostat, depending on what is talking to the valve will determine what it does. So the control valve on its own doesn't do anything. It'll just go to a fail position, whether that's fail open or fail closed. It will stay there until it receives a pneumatic signal to move position. For a liquid dump valve application, we are controlling a liquid level inside of a vessel or a separator. The high pressure control valve would be operating in conjunction with a liquid level controller. So in a pneumatic system, the liquid level controller would sense when the liquid level rises. It would have a 30 psi output that would go to the pneumatic actuator of the dump valve, lifting the dump valve open and helping to evacuate that fluid to bring that level down. In a pressure regulation application, whether that's back pressure or pressure reducing, the high pressure control valve will be used in conjunction with multiple other components. That's going to make a high pressure control valve package. We'll get into more detail on that a little bit later in the video. But just wanted to do a broad overview at first. Temperature control is another application where high pressure control valves are used in. Now, when I say temperature control, I'm talking about controlling fuel gas to a burner, which is controlling temperature. A lot of people use our 1-inch high pressure control valves in this application because of the small trim sizes and the precise control that they offer. So each one of our high pressure control valves has a failure position, either fail open or fail closed. PO just means that it takes pressure to open it. So that would be the same thing as a fail closed valve. And then the PC version is pressure closes the valve or it fails open. So you can use that language interchangeably whenever you're talking to us about what valve you need or in our documentation. The two main types of high pressure control valves that we have are cage guided and stem guided. Main difference between those two types of valves is one is unbalanced and one is balanced. So what I mean by that is the cage guided valves are considered a balanced control valve. And what that means is that as pressure comes into the valve, that upstream pressure is balanced below and above the piston assembly in the control valve. So no matter what pressure drop you have across that valve, even if it's 1,000 psi upstream and 0 pressure downstream, that valve is not going to have any issues opening up against that pressure differential. So the upstream pressure is balanced above and below the piston. Now, on the other side, we have the stem-guided valve, which is unbalanced, meaning that the upstream pressure is above the ball in the stem-guided valves, and the downstream pressure is below. Now, the pressure differential you have to keep in mind with stem-guided valves, because if that increases to a certain point with especially the larger trim sizes that are available, that can keep the valve from opening. So you have an area on top of the ball that upstream pressure is acting on. Let's say if the pressure differential between upstream and downstream is 1,000 pounds, that 1,000 pounds on a 1-inch trim can keep the valve from wanting to open because it's creating a lot of force down, preventing the valve from opening. So in high pressure drop applications, it's something to keep in mind and might help you determine whether you want to use a balanced trim or an unbalanced trim. Another big difference between the cage-guided and the stem-guided control valves are the available body sizes. Stem-guided is available in 1 and 2-inch connection sizes, both flanged and threaded. The cage-guided is available from 2-inch all the way up to 10-inch. So the flow capabilities of the cage-guided valve are quite a bit more. The CV ranges for the cage-guided valves range from about 28 CV all the way up to above 1,000 CV. So it can flow a lot. On the other side, the stem-guided valves, the CV ratings go from about 0.34 all the way up to 21. The trim sets for stem-guided range anywhere from 1/8 inch all the way up to 1 inch. And then the cage-guided valves, they have a full port version and a reduced port version for each connection size. The full port is just going to match the connection size of the cage-guided control valve. The reduced port basically cuts in half the size of that trim. The reasons why you would want to move from a full port to a reduced port would be flow conditions changing. As wells age, they decrease in production, and instead of changing out an entire valve, maybe you just want to change the trim size. And so keeping the valve body in place, you can swap out the internals and get better flow control without having to replace the entire valve. Something similar on the stem-guided side, we have trim sizes that range from 1/8 inch to 1 inch and everywhere in between. And so flow conditions changing, you can swap out trim again without having to change out the entire valve. All that's required to change the trim is to remove the pneumatic actuator and swap out the stuffing box, and the trim set as an entire assembly, or removing the trim set from the stuffing box and just replacing that with a new trim size. The seal class of our stem-guided valves is a class 4 seal, and what that means is that it's a metal-to-metal seat. And so in our process, as we manufacture trim sets, they actually go through a lapping process where we lap the ball of the trim against the seat, and so that creates that really tight seal. And also, because it is a metal-to-metal seat, it's really good in environments where there is abrasion or erosion, because you're not wearing out a soft seat. So it's good in harsh environments. For the cage-guided valve, it's a class 6 seal. So there's actually a rubber seat, but it has a metal-to-metal backup. So it's kind of both class 6 and class 4. But it has a metal-to-metal seat, but then also a seal that makes it class 6. So class 6 is just a bubble-tight seal. So a little bit better sealing capability, but still robust and can stand up to erosion. Other factors that would determine whether you use cage-guided versus stem-guided, or even a regulator versus a package buildup with a high-pressure control valve, is flow. You don't only have to use high-pressure control valves for high-pressure applications. They can be used anywhere within their operating pressure. So whether that's 1 psi all the way up to, some of our connection types can go up to 6,000 psi. So it just depends on your operating pressure. But just because they're called high pressure control valves doesn't mean you have to use them only in high pressure applications. We see a lot of our stem guided valves be used in really low pressure applications because the CV requirements are very low. So to get really tight control under those conditions, you need something with a very small CV. And so using a stem guided valve can help you achieve that flow control under those types of conditions. Even though it's not high pressure, it's really tight, precise control. So in harsh environments where there's erosion, lots of sand and abrasives, choosing a high pressure control valve for that dump application you can get better life out of that valve and maybe not have to swap out that valve or change and repair the valve where you would have to do that with the low pressure control valves. Next, I want to talk about the actuator crack pressure. This is a chart that we have in our documentation for these valves. Depending on the pressure differential across the valve and the spring that you have in the actuator, that's going to determine when that actuator begins to open. Let's say you have a really high pressure differential for a stem-guided valve, and you want to know when that would be able to start opening. So for an example, let's just take this very first line. So we have a 1400 SMT PO. So that is a 1-inch, 4,000 pound body. It is threaded. It's a motor valve. It's a through body. The PO stands for pressure open. So our pressure is opening this valve. So as we increase the pressure differential, it goes all the way up to 1500 PSI. So we're looking at the valve that has 1/8-inch trim or 1/8-inch inner valve. That's what IV stands for. So at 1,500 pounds with a 10-pound spring in it, which I wouldn't necessarily recommend because that's a really large differential, especially in a pressure to close application. You would want that to have a heavier spring. But let's just, for example, look at it. So crack pressure is at 2 psi, so it begins to crack that valve open at 2 psi. And then fully opens the valve once that supply pressure gets up to 6 psi. So finding your valve on here, knowing the differential pressure, and then knowing what spring you have in your valve will help you determine where the crack and full open pressure is. All of our pneumatic actuators for our high pressure control valves for both cage guided and stem guided valves have a maximum working pressure of 45 psi. If you send more than 45 psi to our pneumatic actuators, you can compromise the diaphragm. A symptom of a compromised diaphragm is continuous venting from the actuator. One side of the actuator holds the pneumatic supply or pneumatic signal to move the actuator, and depending if you're pressure open or pressure closed will determine what side of the actuator that signal goes to. But on the other side, opposite of the signal on the diaphragm, is just atmospheric pressure, and there's a breather plug there that allows atmospheric pressure in and out of the actuator. All of our control valves work with 30 psi actuator pressure. So whether you're using compressed air, nitrogen, or natural gas for supply, with a standard setup, 30 psi is all the supply pressure that you'll need to actuate that valve. So if it's compromised and it's continuously venting, it will need to be replaced. We offer repair kits for all of our controllers, all of our valves. So you can also find that information on our website if you're looking for what repair kit you need for your specific valve, or you can give us a call and we can help you find that. So we've talked a little bit about PO valves versus PC valves, or fail closed versus fail open valves. When do you use one versus the other? So for any back pressure regulation package, that package is going to come standard as fail open. The reason for that is because you are monitoring and controlling upstream pressure. And so the equipment upstream needs to be protected so that valve will fail open, relieving that pressure to the downstream side. For pressure reducing packages, you're monitoring and controlling downstream pressure. So that's what's most important. So if something were to go wrong in that system, you want that valve to fail closed, protecting what's downstream of that valve package. So back pressure valves are standard fail open. Pressure reducing valves are standard as fail closed. Any control valve can be swapped from pressure open to pressure closed without having to buy any extra pieces. There are many different trim materials and types for our high pressure control valves. The trim types are used based on application. So we have equal percentage trim or EP trim. We have linear trim, which could also be called nominal trim. And then we have snap trim, which could be called quick opening, which could be called CB or carbide. There's a lot of different names for that one. But each one of those trim types has a specific application in mind. EP trim is used for the tightest control. So in applications like pressure regulation or flow control, you would want to use EP trim. So the way that it works is as the valve trim opens, the CV rating slowly increases, has a very slow ramp to full open. The nominal trim is used in kind of your standard liquid dump applications. It's more of a 1-to-1 ratio, so 10% of the trim opening equals about 10% of the flow, and so on, all the way through the stem travel. So non-erosive liquid dump applications typically use nominal trim. Carbide trim is used for erosive liquid applications, so where you have heavy sand or other debris in the flow stream and you're having problems with trim sets not lasting, you might consider going to carbide trim or even zirconia trim, which is kind of a step above carbide, for those extremely erosive applications. We also offer different trim materials for each one of those. So we've got our kind of standard D2 tool steel material, which is a hardened material. It's great for most applications. But then we also have different stainless steel options for sour service. So 316 stainless steel, 304 stainless steel, 17.4 pH stainless steel, which is kind of a hybrid between wanting to prevent corrosion and erosion. So it's got properties that make it work well in both applications. All of these different trim materials make our offering really robust and make these valves last in whatever application you have, whether that be erosive or corrosive applications. We have a materials guide for our high pressure control valve trim options and cages, and we also have an Elastomers guide that we'll put a link down below. So I mentioned before high pressure control valve packages and the components that are used to make that package. In this example, we have a 30 HPG pilot, so that operating range is from 10 to 300 PSI. We also have other models of pressure pilots that can go from anywhere from 10 PSI all the way up to 2,500 PSI of controlled pressure. So depending on what you're using it for will determine what pilot you select. We also have a drip pot, which takes upstream pressure and removes any liquids that are entrained in that gas. We have a supply gas regulator, which takes that higher pressure and cuts it down to 30 PSI, which is what our actuator requires. That's the supply gas pressure that the pilot uses to send to the valve actuator to get the controller to move. Then we have a sense line protector. So what that is doing is that's ensuring that if pressure ever goes above the maximum operating pressure of the pilot, that sense line protector will close and protect the pilot from being overpressured. You want to make sure that there is some safety device in between that upstream pressure and the sense port of the pilot. So that's what the sense line protector is doing, is just ensuring that no more than 300 pounds go through to the pilot and overpressure the diaphragm. Now we're going to look at a high pressure control valve package that's a pressure reducing regulator. They'll have those same main components, but they'll just change slightly depending on the working pressure of the valve package. One less commonly known pressure package that you can put together is a high-low package. What this does is it makes sure that that valve stays open as long as the controlled pressure or the sensed pressure is between two set points. So you will have a lower set point pilot and a high side pilot. So as long as the pressure it's sensing stays in between the two set points, the valve remains open. If the pressure ever gets too high or too low, it will close the valve. Where I've seen these pressure gap controllers or high-low controllers used is on the wellhead. So you're wanting to, let's say you're doing gas lift and you're wanting that well to remain open as long as the pressure is in between two set points. So you want the well to remain open as long as it's between 1,000 pounds and 1,500 pounds. If it gets lower, you want the well to be closed in so that way it builds pressure. Or if it gets too high and it's going to overpressure your equipment, you want that valve to go closed. So 2 set points, and it operates anywhere in between and closes if it gets too high or too low. Another not very well-known product in our high pressure control valve line is the non-freeze dump valve. Its main job is to utilize the internal temperature of a vessel to help mitigate the issues due to a JT effect. And so when you have large pressure drops and consequently large temperature loss, you can have freezing problems on the outside of that valve. What the non-freeze valve does is it takes that trim set and where that pressure drop happens, and it puts it inside of a vessel. So you can utilize vessel heat, or it's shielded from ambient cold temperatures that might make that effect even worse, and you can avoid freezing. Typical applications, it's used on gas production units for dump valves. So really high pressure drop applications, condensate, or other liquids that you're dumping from those vessels. Typically they're installed on top of the vessel, so there's a stinger that you have to install to get down to the liquid level inside of the vessel. But that's the most common application for the non-freeze dump valves. Metering valves are another model within our high pressure control valve family. These metering valves are manual valves, so you manually turn the valve open or closed to choose the position of the trim. In applications where you're not needing the control valve to change positions on its own, you want the valve to go a certain percentage open and remain there. You can do this for initial pressure cuts or other pressure choking applications. But there's a few different sizes that we offer. We have a whole video on how to read the scale on the label of the metering valve, so if that interests you, we'll link to that below. There's also a valve body variant. It's called the T-body. The T-body is used in applications where erosion is a major problem. If you're having valve bodies wash out due to erosive liquids, you can use the T-body to help prevent that. The T-body uses a wear plug in place of the valve body, so that way the wear plug takes the brunt of the damage and it can be replaced. It's also made of a hardened material that will last longer than a standard valve body will. So a T-body can be used in both angle body applications, but also through body applications where you see excessive wear due to erosion. So far in this video, I've talked a lot about pneumatic actuators, fail positions, but for our high pressure control valve bodies, we also offer an electric actuator. So this would take the place of our pneumatic actuator and allows the high pressure control valve to be used in automation, and it can also be used with any electrical component, whether that's for pressure control, flow control, temperature. All those different applications can be used with our electric actuator. We also offer three-way valves or splitter valves. These can divert flow from one process to another. They are continuously flowing either one direction or the other. Where I've seen these used is in fluid temperature control. So if a fluid temperature drops below a certain temperature, it's diverted to a heater where it can get heated up. If it meets that temperature requirement, it diverts the flow to a different process. So that could be done with gas and liquids, depending on your needs. But you can check those out on our website. All right, so we get a lot of questions about our high pressure control valves. One that I've gotten quite a bit is, can you mount the high pressure control valves on their side? Yes, you can. Typically, people will do that because of room restrictions they're trying to work around, or existing piping installations where they don't want to change the piping direction and they just want to install the valve kind of as is. The issues that you run into when you do install a high pressure control valve sideways is that you get uneven wear on the valve packing, and the oil that's in the valve actuator cannot lubricate the stem O-ring, which helps keep that seal from the pneumatics. And so you'll get premature wear on those components and earlier failures where you wouldn't see that if it were installed upright. With some of the larger valve sizes, I wouldn't recommend that because there is a lot of weight. That valve actuator is really heavy, and so it can put unneeded stress on some components that would just cause early failure. So with a 1-inch valve, you may not see a whole lot of change, except with the O-ring not being lubricated. But with the larger valve sizes, that effect is just going to get greater and greater, and you're going to have faster and faster failures with those larger valves. Using our electric actuator takes all of that away. So there won't be any premature wear on our electric actuator. It doesn't require any lubrication of a stem. There will be some, especially with the larger valves, as I mentioned, some early wear on the packing, but there's no concerns with the valve actuator itself being installed in this way. All right, so the question I get quite a bit having to do with the valve actuator is, how much oil should you put in the valve actuator to lubricate the O-ring? You want to make sure that you're covering the communication hole that's in the valve actuator. Just make sure that the oil level is above that. That way that oil can be communicated to the O-ring, keeping it lubricated. Another question that we get quite a bit is, can I change my trim size once I've installed my valve? And I mentioned this a little bit earlier in the video, but yes, you can change out or swap the trim size without having to change the entire valve. It's a pretty easy process. We've got a lot of videos on how to do that, and even a full repair on the valve itself. All it requires is to take off the actuator and replace the valve trim. That's a pretty simple process. Thanks for watching this video. If you have questions, you can contact Kimray support or comment below.